Anne, your milk is getting cold.
It's so hot outside. Chilled water tastes so good.
Make sure you put the bottle back in the fridge. The water will become warm if left outside.
But yesterday you said the milk was getting cold when it was lying outside. How can one thing become cold and the other warm in the same environment?
Anne has a valid question. Have you also wondered about how objects become colder and warmer? The answer lies in the phenomena of transfer of heat. At the end of this lesson, you will be able to demonstrate through examples that heat flows from a hotter object to a colder object. List the 3 methods of transfer of heat. Explain how heat is transferred through conduction. Explain how heat is transferred through convection. And explain how heat is transferred through radiation.
There is a simple answer to your questions. Heat flows from a hotter object to a colder object.
Meaning?
When milk is heated, its temperature rises quite high, right?
It sure does.
So, when we take it off the flame and put it on a table, the milk is hot, but the surrounding air is relatively cooler. The heat from the hotter body, which in this case is milk, is gradually transferred to the particles of the surrounding air that are comparatively cooler. That makes the milk lose its heat and gradually cool down.
Okay, but the water bottle is already cold.
Well, try touching it now. It's been out of the fridge for a few minutes. Does it feel as cold as it did when you took it out?
No, it feels slightly less cold now.
Exactly. That's because, in this case, the air surrounding the bottle is comparatively warmer than the bottle, and the water in it.
Oh, you mean heat is getting transferred from the air to the bottle now?
That's right. There are many more examples of transfer of heat right here in the kitchen. Can you point out one to me?
That's easy. For cooking, when you place the wok on the flame, the heat transfers from the flame to the wok.
Very good. And why do you think I'm wearing a glove to hold the spoon to stir the stew?
Oh, I guess the spoon is hot. Let me check.
Careful, you'll burn yourself.
Ouch! I can see that's getting quite warm.
Yes, the heat from the stew as it cooks gets transferred to the spoon that I'm using to stir it.
So, heat is getting transferred in all the cases that we spoke about.
That's right. However, the mode of transfer of heat in each of these cases is not the same.
Really? What's the difference?
Well, actually, there are 3 modes in which heat can be transferred from one object to another. They are conduction, convection, and radiation.
Oh, what are these modes?
I'll explain the methods one by one. Remember how the wok gets heated when placed in contact with the flame?
Yes.
The heating of the wok and the spoon placed in it are results of conduction of heat. Heat from the flame gets transferred to the wok.
And when you touch the spoon, the heat from the spoon gets transferred or conducted to your hand.
Yes. The process by which heat is transferred from the hotter part to the colder part of an object without the movement of the particles of that object is known as conduction.
Mom, how could you hold those handles? Didn't the heat sting your hands?
Don't worry. The handles of this wok are made of Bakelite, a heat-resistant material. These handles don't get hot.
I don't understand.
Here, I'll show you what I mean. I have replaced the steel spoon in the wok with a wooden spoon. Try stirring the stew using this spoon. You don't need to use gloves.
Really? Yeah, you're right. It doesn't feel hot at all.
Yes, because this spoon is made of wood, and wood does not allow heat to pass through it easily. Because of this, wood is referred to as an insulator of heat. Materials that do not allow heat to pass through them are called insulators. Similarly, materials that allow heat to pass through them are called conductors. Rubber, wood, cork, paper, glass, Bakelite, and ceramic are some examples of insulators of heat. Try holding this tumbler with tea in it. Feels hot, doesn't it?
Yeah, it's difficult to hold.
Here, I pour the tea in a ceramic cup. It's easier to hold now, right?
You're right. Is it because ceramic is an insulator?
Correct. It is because steel is a conductor and ceramic is an insulator of heat.
Cool. Now if the burner is free, can I pop some corn?
Sure. Do you realize, though, that conduction plays a role when you pop corn in a cooker on the flame?
How's that?
Heat from the pan gets transferred to the oil, and from the oil to the kernels of the popcorn. Did you know transfer of heat through conduction occurs only in solids? This is because particles of solids cannot move.
Delicious.
The interesting thing is that corn can be popped using all the three modes of heat transfer.
Oh, right. You spoke about convection and radiation as well. What happens in convection?
Remember your lovely holiday by the sea last year?
Oh yes, we had such a great time. And the weather was so nice all through, unlike the harsh summer we have here.
The reason for that lovely weather lies in the phenomena of convection. Convection is the transfer of heat by the movement of particles of a medium from one place to another. It takes place only in liquids and gases. I'll show you a simple experiment to help you understand what happens during convection. We will need a cylindrical glass trough, a lit candle, a lit incense stick, adhesive tape, and a circular cardboard with two identical holes.
Here we are. What do we do next?
We start by placing the lit candle in the trough. Let's cover the trough with the circular cardboard in such a way that one of the holes is right above the lit candle. Now, I will fix the cardboard to the trough with an adhesive tape all around. Place the lit incense stick above the other hole of the cardboard. Now, watch what happens to the smoke coming from the incense stick.
Oh, the smoke from the incense stick is going into the trough. Shouldn't it be rising? And it's coming out through the hole above the candle.
Yes, this is happening because the hot air above the lit candle rises. When this happens, the cool air above the cardboard enters the trough to take its place. The smoke that is emitted by the incense stick is pushed into the trough when the cool air comes down. However, warm air rises again, and it comes out from the other hole that is above the lit candle. Similarly, the temperature weather in places near the sea can be explained. Land near the sea gets heated faster than water.
Is it because solids get heated faster than liquids?
Yes. Solids heat up faster than gases and liquids as well. During the day, the air over the land becomes hot and rises. This creates a low pressure area or a gap between the land and the hot air. Cooler air from the sea then rushes in towards the land to fill up the gap created by the rising hot air. This is sea breeze. The cooler air in the upper atmosphere moves down towards the sea to complete the cycle. Due to this cycle, land near a seashore stays cool throughout the day. This is nature's way of showing us convection.
And what happens during the night?
At night, the reverse happens. The sea cools down more slowly than land. So, the land at the shore cools down faster, resulting in the cooling of the air above the shore. Thus, the air above the sea at this point is comparatively warmer than the air above the land. As the hot air over the sea rises, cool air from the land rushes into the sea to take its place. The cool air that flows from land towards sea is called land breeze.
Oh, so due to convection, the atmosphere at the seashore always remains pleasant. I'm in the holiday mood again. Can we pop some more popcorn? You said we could pop it through convection of heat as well, right?
Yes, if we had a popcorn popper, we could try the convection method as well.
Mom, what was the third type of transfer of heat that you mentioned? Radiation, right?
Right. You remember how the milk, when kept away from the flame on the table, gradually cooled down? That happened because it transferred its heat to its surroundings by radiation as well as convection.
What exactly is radiation, Mom? I think I've heard the term before.
You would have heard the term being used with regard to the sun's radiation. Radiation is a process in which heat is transferred from one object to another either through a medium or vacuum. So, the remarkable thing about radiation is that heat is transferred even in the absence of a medium. Oh, you do know that the sun is situated very far from the earth, and air exists only up to 300 kilometers in the Earth's atmosphere. It's vacuum beyond that.
Yes, I know.
Despite that, we receive heat from the sun.
Because of radiation.
Exactly. For that matter, not only the sun, heat is radiated by all hot bodies. Our bodies too give out and receive heat due to radiation. When heat is incident on some object, a part of it is reflected, a part is absorbed, and a part is transmitted. The heat that is transmitted from the object and absorbed by the surrounding objects increases their temperature.
So when we sit near a bonfire in the winters, we feel the heat of the flame through radiation?
That's right. You may have noticed particles of ash flying up in the bonfire. That's a result of convection. The air above the flame becomes hot and rises, taking the particles of ash with it.
This brings us to the end of this lesson on transfer of heat. In this lesson, you learn to demonstrate through examples that heat flows from a hotter object to a colder object. List the 3 methods of transfer of heat. You also learned to explain how heat is transferred through conduction. Explain how heat is transferred through convection. And explain how heat is transferred through radiation.